Record. Okay, we are now recording. Share my screen. Okay, so hope you had a good weekend. We're back in business, so to speak. So we only have 3 days of class this week just because of the holiday. So we're here. So Tuesday, Wednesday, Thursday. So the goal for this week is to finish chapter 4, 4.7. And so quiz is Thursday, which is fast. Another nice thing about 4-day weekends, you know, is the day you go back isn't Monday. The day you go back is already Tuesday. So even though it's the first day of the week that we're studying, it's already Tuesday, which means Thursday we're already done again. So quiz on Thursday, but the next exam will be the 25th. Okay, and the coverage is chapters 3 and 4. So again, I'm going to get started with chapter 5. I'll do quite a bit of chapter 5 next week, but the exam will be stuff here. Okay, so whoops, chapters 3 and chapter 4 over here. Okay, so that's what's happening. And let's see. Okay, so Alex, I got you. So that's fine. Whoops, made a mistake there. Try that again. I'm getting there. All right, here we are. Okay, so the goal is 4.2 and sum of 4.5. Again, we're not doing 4, 2, 3, 4, and 5. That looks like a lot, but we're not scheduled to do, maybe I just picked up. So my goal is to do 4.2 and sum of 4.5 today, and then that should be fine. Okay, next order of business is this. Okay, so I got myself a headset right here. I'm going to give that a shot and see if that helps with audio, because I know some of you saying it crackles or it comes in and out or it's just static and blah, 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 or something like that. So let me give this a try. Plug this in. Testing 1, 2, 3, 4. And maybe if you feel like somebody give me a comment on whether you think this is better than before or worse than before or same thing or it doesn't matter. So how does this sound to all of you? Let me check. Sounds good, better, way better. Okay, all right, then I guess this is a way to go, much better. Great, okay, all right, thank you for those of you that are trying. You're not gonna get graded on replying necessarily, but yeah, okay. So hopefully this will make things better. And I'll listen to the recording later also. So I know what it's like without it because I play it back and I hear the crackle and, you know, buzz and bzzz and stuff like that. So hopefully this will take care of some of that. I know some of you have this thing also. In fact, I'm not an expert on this, so I may need to ask some of you for help on ins and outs on this. One thing I'm noticing is I kind of hear a little echo for myself. It's like I hear me is maybe the way you say it. Or if anybody knows a way that do that, maybe the mic is too close to me. Yeah, maybe that's a thought. But I'll see. Oh well. But most of you are commenting this is better, so we'll see how it goes from here. Okay. And the other thing about this is I'm more tied down, so it's harder for me to reach over stuff because I've got more wires and everything here and there. And I'm noticing that some of you have this also, so you're probably used to it, but I'm not. So I may be asking some of you guys for help for this from time to time. Okay, so it looks like this is the way to go from here. Okay, so let me move this over. All right, so we're doing graphs of parabolas today. So the topic is quadratic functions. So we've seen some of this before in algebra, but we're going to dig a little bit deeper. So 4.2 quadratic functions. Okay, let me turn off the chat temporarily. Oh yeah, another thing. We are probably going to end early today because I have a meeting to attend to. And so, yeah, I know a lot of you are probably disappointed about that, but there's a good chance that I'll end early today. And I think next Tuesday, I may have to end early also. but we'll see how it goes. Okay, quadratic functions. Okay, that means they look like this. Y equals ax squared plus bx plus c. Okay, they look like parabolas. Okay, so on page 233, okay, you see something called the vertex. The vertex is either the lowest point or the highest point. So we're going to look at ax squared plus bx plus c. In case you're wondering about, I heard you say quadratic formula. Quadratic formula, you might recall, instead of a y, there's a 0, right? If I put ax squared plus bx plus c equals 0, there's a quadratic formula. But now it's just not 0, it's just any letter y. The graphs all look like parabolas, okay? If a is greater than 0, a is positive, the parabola opens up, okay? If a is negative, then a opens down. I think you've seen that before, okay? This is an axis of symmetry. So if you take the vertical line going through the vertex, there's a mirror image, right? The left side and the right side are mirror images of each other. Same thing over here. The left and the right side are mirror images of each other, okay? And you can put this on your next formula sheet if you wish, okay, on page 233. So ax squared plus bx plus c equals y, or it might say f of x. This is called a quadratic equation. They look like parabolas. Okay, if a is positive, opens up. Vertex is the minimum, it's the lowest point. If a is negative, like if it's -2 or whatever, then it opens down and the vertex is the highest point. Okay, and in both cases, you see there's an axis of symmetry, a vertical line going through the vertex. Okay. So now, how can we get the vertex? Now, you should already be familiar with y equals x squared and y equals -x squared. Okay, so if I draw something like this, this is x squared. This is -x squared, is that right? They both have a vertex at the origin 0, 0. So that's a basic parabola that you want. Okay, and notice even if it's just x squared, the coefficient is 1. There's a 1 in front. That's positive, that means it opens up. The negative means the coefficient is -1, so it opens down. Okay, and we've also seen before that if you replace a function with its opposite, right? If you replace x squared with -x squared, that gives you the reflection across the x-axis. So now it looks something like this. Okay, now they might give us a parabola like this, a x minus h squared plus k. Okay, well, that would just be my translation ruse, right? That moves h units to the right and k units up. So the vertex, which used to be the origin, is now at h comma k. So the vertex, which I'll abbreviate with v, is h comma k. So if they give you an equation that looks like this, okay, the vertex is hk, because how does this translate? Again, translate means move. That's h units to the right and k units up. Okay, that's assuming k is positive. If it's negative, then we know it goes down. If h is negative, then we know we go to the left instead of the right. So the vertex is h comma k if it's given like this. Okay. Now, if they give you the equation just like this, okay, and most of the problems will look like this. The problem doesn't look like this, but it looks like this. Okay, then how do we find the vertex? There's a formula for it, which I'll give you. It's provable. It's best to prove it with calculus. We're not in calculus, so maybe your Calc 1 teacher will prove it to you or not, but it doesn't really matter. So if it's given like this, the vertex is at x equals -b over 2a. Okay, so that's a formula for the vertex if your equation looks like this. Okay. And we know the vertex is either the high point or the low point, maximum or minimum. Okay, so here the vertex is a minimum, I'll abbreviate with min. And here the vertex, I'll abbreviate with V, is a maximum. Okay, so we'll have some word problems later involving maximum and minimum where we have to find a vertex. The vertex will give you the maximum or the minimum. So right now, just take it that X is equal to negative B over 2A. That will be the vertex. You can prove it with techniques of calculus. For now, we'll just state that's where the vertex is. Okay, it's either going to be the high point if the parabola opens down, or it's the low point, the minimum, if the vertex is like that if the parabola opens upward. Okay, and again, we can tell by the A, this one, A is positive, here A is negative. Okay, let me do the uncurling again. And go from this. Okay, again, put this on your next cheat sheet for the next test, if you would. Okay, let me move this out of my way here. Notice I kind of get more wires here that can get me all tangled up. Okay, so they give me the equation like this. The vertex is H comma K. Just think of your translation, move it left, right, up, or down that we did before, right? If they write it like this, you could force this to look like that. In fact, that's one way you could prove it. You could force this equation to look like this, in which case the vertex is at X equals negative B over 2A. We'll just take the shortcut that this is how to find the vertex and go from there. Okay, so let's try to get started with some of these problems now. So what do we have? 5 to 29, 37, 39, 41. Okay, so as usual, I'll do a bunch and go from there. Okay, graph the quadratic function, page 243. Specify the vertex, axis of symmetry, maximum, minimum value, and intercepts. Okay, let me get this out here. Okay, so let me check the homework again. It was 5 to 29, 37, 39, 41. Okay, so I'll show that to you for those of you that aren't getting the book. So there's 5 through 20-ish, 21 to 29. Okay, and then on the next page, let's see, 37, 39, and 41. 37, 39, and 41. Oh yeah, so it's the F circle G stuff again. Okay, so that's everything that you need there. All right, so let's start with number 5. Y equals X plus 2 squared. All right, so that kind of fits like this. Now you might say, well, there's no plus anything. Well, you can pretend that it's a plus 0. I'll go ahead and sneak that in, plus 0. All right, so now this looks like this. So the vertex is, you take the opposite of that, but keep that sign. So the vertex is negative 2, 0. Okay, or you could just take our translation rules, right? That we said before. This is y equals x squared, right? And you might recall if we replace x by x plus 2, that moves the graph 2 units to the left. So 0, 0 now becomes negative 2, 0, but the rest of the graph is the same. Okay, and it's going to open up. The coefficient of A is 1. If you multiply all this stuff out, A is 1. Okay, so very rough sketch of this thing. All right, so the vertex used to be 0, 0. It's now negative 2, 0. Like that. Okay, let's see. They asked for intercepts. What do you get when you plug in 0? 0 gives me 2 squared is 4. Okay, and there's an intercept here, negative 2, 0. Okay, and I already know it opens up, so I have enough just to draw the graph generically, sort of. So there's a quick rough sketch of the graph. Okay, and looks like this is a minimum. So the vertex, I'll put V for vertex. So if we know we're talking about parabolas, V is for vertex. They ask for the intercepts. So there's an intercept at -2, 0, 0, 4, and that's about it. As for the axis of symmetry, the axis of symmetry is always the vertical line going through the vertex. So there it is. X equals -2 is the axis of symmetry, or sometimes we just say axis. Okay, you might recall that for a vertical line, vertical lines look like X equals a constant. So X equals -2 is my axis of symmetry in this case. Okay. All right, so that's it for that one. Okay, so again, if the equation looks like this, you can get the axis of symmetry just by reading off. Okay, H comma, okay, so you change that sign, but you keep this. So change the 2 to -2, but you keep that 0 over there. Okay, I'll show you one more like that. Number 9. Okay, 9 says y equals -2 x plus 2 squared plus 4. It looks like that. Okay, so the vertex, change the sign, but keep the sign. So it's going to be -2 and 4, like so. -2, 4. Okay, and I see some stuff in the chat, so let me get that quickly. Let's see, just where we are here. Okay, yeah. Yeah, maybe I should have put that down, sorry. So this is section 4.2, page 243. All right, there's a negative here. So does that mean it opens up or down? A is negative, it opens down. So the parabola is going to go like that. So the vertex is a maximum. It's going to be a maximum. Here it was a minimum. It was the lowest point. Here it's a maximum. Okay. So for intercepts, this might be a little bit of trouble. Okay, let's plug in x equals 0. So put a 0 there. -2 times 2 squared is 4 plus 4. So what does that come out to be? -2 times 4, -8, -4. 0, -4 is the vertex. Oh, I'm sorry, that's not the vertex. That's just an intercept. We already have the vertex as -2, 4. That's right. Sorry. That's just an intercept. Now it asks for other intercepts. So let's try y equals 0. Okay. So put a 0 here. 0 equals -2 x plus 2 squared plus 4. Solve for x. Okay, it looks like this one's going to be kind of messy. Okay, let me add that, move that over to the other side. 2 times x plus 2 squared equals 4. Divide by 2. Okay, how do I get rid of a square? Square root. Square root. Square root. Plus or minus. Don't forget the plus or minus. X plus 2 equals plus or minus radical 2. subtract 2 on both sides, so I get these messy values. X is -2 plus or minus radical 2. Okay, so what is that? Okay, on a calculator, this is about 1.4. So this is roughly -3.4 and -0.6. Okay, so that just gives you a crude approximation of where we are here. Okay, so I think we have everything we need. That's our highest point, that's our maximum. So let's try to graph this. So I got to go out to -4-ish maybe. One, two, three, 1, 2, 3, 4. The highest is 4. 1, 2, 3, 4. I don't really know how far down I have to go here, but we'll just give it a try. And let me uncurl the paper again, sorry. Paper tends to curl on me occasionally. Okay, vertex is -2, 4. That's the highest point. So -2, 4. It's a maximum. I'll abbreviate maximum with max, minimum with min, M-I-N. So that's a maximum. Okay, if I draw a vertical line through that, that'll be my axis of symmetry, or just axis. X equals -2 is my axis. So for these problems, the axis or axis of symmetry is always going to be X equals blah, 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 not Y equals. And you might recall from your algebra, the equation of a vertical line is X equals something. Okay, I'll just put some of these other key points. Let's see, I had 0, -4. 0, -1, 2, 3, 4 is way down there. And it touches the x-axis at here. In fact, I should have written this. So I have -2 plus or minus radical 2, 0. So where is y equals 0? At about -3.4. 1, 2, 3, and a little bit more. And -0.6, that's about -0.5. Okay, so I think I have enough points to show you the graph looks something like this. All right, so that's what we got. Opens down. Here's my vertex. This time it's a maximum. Here it's a minimum. So they give me the equation where it looks like this, something times parentheses squared plus a constant. You can just read the vertex right off, h comma k. -2 comma 0, -2 comma 4, and so on. Okay. And yeah, let me raise this up again for focusing purposes. Okay. So like that and like that. Okay. In order to get it to focus, I have to raise up my paper since I don't have a focus button on this document camera. All right. Okay, that's how you handle those. Now, what do I do if I see stuff like this? You can't see it so well. Okay, so there you have to use the other formula I gave you, ax squared plus bx plus c. Okay. So the vertex is at -b over 2a. Okay, so I'll show you some of those right now. All right, so how about I start you off with number 11? Whoops. X squared minus 4x. And of course, whenever it says f of x, you can pretend it's y, right? Y equals f of x, but they're telling you it's a function. Well, as long as I'm at it, I might as well factor x times x minus 4. So let's get the intercepts out of the way. 0 gives me 0, and 4 gives me 0. So 0, 0, and 4, 0. All right, so when it's like this, A is 1, B is -4. We don't really need it, but can you see what would C be? Since I don't see anything, it's 0, right? If you had to do a quadratic formula on this, you could pretend this is like +0. But in reality, you don't really need it because in our formula for the vertex, x is -b/2a. There's no c involved. So I didn't really have to worry about it. All right, so where's the vertex? It's at x equals -b/2a. So what is -b? -4, 4 over 2 times a, 2 times 1. So that comes out to be 2. Okay, and I need the y coordinate. How do I find the y coordinate? Just plug in. 2 squared minus 4 times 2. Put a 2 there, put a 2 there. So that's going to be 4 minus 8, -4. So 2, -4. Okay, so what am I doing this time? If they give you the equation like this, it doesn't look like this parentheses stuff, but it's just ax squared plus bx plus c. Then the vertex is at x is -b/2a. This is a side note, but that looks like part of the quadratic formula, doesn't it? In fact, the quadratic formula has this, and then there's that plus or minus square root of b squared minus 4ac stuff, right? But the quadratic formula has a -b/2a. If you just kind of ignore all the square root stuff, that's what it would look like. That's another way of thinking about it. Okay, so there's my vertex. Okay, a couple of quick questions. Does this parabola open up or down? And how do you know? Is it U-shape or upside down U-shape? It's based on the A. A is 1. I mean, it's going to open up. It's positive, so it looks like this. Okay, and therefore the vertex is a maximum or a minimum. Look at the turning point. It's a minimum, right? That means it looks like this. If A is negative, like this one over here, right? Then the vertex is a maximum. It's the highest point. In case you want to know what's going on with these word problems are basically finding the vertex. And then you'll determine, is it the maximum or the minimum? Okay, so let's see, I got 0, 0, 4, 0, and 2, -4. Let's plot those and see what happens, right? One, 2, 3, 4. 1, 2, 3, 4. X, Y. Whoops. Myself tangled up here a little bit. Okay, 0, 0, 4, 0. 0, 0, 4, 0. And where is my vertex? 2, -4. 1, 2, 1, 2, 3, 4. And I know that's the lowest point, right? Vertex 2, -4. It's a minimum. All right, so I get my U shape just as I anticipated, because I know it kind of looks like this. Here are my intercepts. Draw a vertical line through the vertex, and that is your axis of symmetry. So what's the equation of the axis? It's always x equals something. In this case, x equals 2. Axis of symmetry. Okay. Okay, the other one I was going to show you was 19. There's some things a little bit trickier about 19. S equals 2 plus 3t minus 9t squared. Aha. S and t. Okay, you'll get that a lot more when you take calculus, or maybe some of you have this in physics, this is meant to be a distance and this is a time. Okay, but right now this is functioning like y and this is functioning like x. So in my graph, t is going to be horizontal and s is going to be vertical. Okay, so this is often used as distance as a function of time, as they say. This is distance and this is time. Okay, the other thing I noticed is this is out of order. I got to make it look like this. So the t squared should be first and then the t and then the number. So let me write it as negative 9t squared plus 3t plus 2, right? The t squared comes first, and then the t, and then the 2. So that's my A, B, and C. Okay, so some fundamentals. Will this parabola open up or down? And how can you tell? Negative, right? So negative means it's going to open down. So sometimes I just draw myself a little reminder. It's a parabola opening down. Therefore, the vertex is going to be a maximum or a minimum. Take a look. It's a maximum, right? So once I find a vertex, it'll be the highest point. So here we go. The formula for vertex is x is negative b over 2a, or in this case, t, negative b over 2a. So negative b is negative 3, right? Over 2 times a, which is negative 9, which is negative 3 over negative 18, which is positive 1/6. That is very clumsy, unfortunately. Not a very nice point. But be that as it may. Okay, I need the y coordinate. To find a y coordinate, I plug in, and that even looks like a headache. So s of 1/6 as a function instead of f. Okay, I use the letter s because that's what they gave me. So plug in 1/6 right there and right there. So negative 9 times 1/6 squared plus 3 times 1/6 plus 2. Oh boy, that's quite messy, right? I should put an equal sign here. Equals and a negative. Okay, so put 1/6 there. What's 1/6 squared? That's 1 over 36, right? 3 over 6, that's 1/2. Plus 2, that's going to be negative 1/4 plus 1/2 plus 2. 2 1/4 or 9/4. 1/2 minus 1/4 is 1/4, right? Add 2, so 9 over 4. So the vertex is 1/6 comma 9/4, and that's going to be the maximum value. Okay. Now I have to find the intercepts. That also doesn't look very nice. Well, I can tell what happens when I plug in 0. When I plug in 0, I get 2, right? So 0, 2, that's easy enough. But now let's set s equal to 0. That's functioning like y. 0 equals negative 9t squared plus 3t plus 2. Okay, I don't think I like this. Let me multiply both sides by negative 1 because I like the leading coefficient to be positive. So 0 equals 9t squared minus 3t minus 2. Okay, does it factor? Well, we can try it. If it doesn't factor, we can always use a quadratic formula, right? But let's try to factor it. See, how do you get 9, 3, and 3, right? So 3t, 3t. How do you get 2, 1, and 2? And see, you want to end up with a negative. So I think I can get a negative if I go like this, right? For that back out, 9t squared minus 6t plus 3t is minus 3t and then minus 2, right? That works. Okay, so either this is 0 or this is 0. 3t plus 1 equals 0, or 3t minus 2 equals 0. Okay, now you want to start to get some proficiency in doing this in your head. Okay, by the time you get to calculus next semester, if you guys take calculus, some of these quote unquote easier algebra details you want to be able to do quickly because you're focusing on so much other weird stuff when you get calculus. Okay, can you do this in your head? You would subtract 1, right? Divide 3. So what fraction do you have? Negative 1/3, right? Okay, and can you tell what's going to happen there? You would add 2, right? Add 2, divide 3. 2/3. Okay, and that's with y or s equal to 0. So the ordered pairs are negative 1/3, 0, and 2/3, 0. Okay, I have everything. It's going to be a very clumsy graph. I have to turn the paper over for that. I plot that, and 0, 2, and 1/6, 9/4. Well, it looks like all the action is not very far. How about for x, I'm only going to go from negative 1 to 1 because I got negative 1/3, 2/3, 0, and 1/6. So negative 1 to 1. And that's like 2 1/4. So I'll do that in my graph. Okay. So I'll show you how I'll do the graph. Turn the paper over, unfortunately. Okay, it's all fouled up because we're used to x and y. X and y is now t and s. So t is like x. Right, we're used to x and y. So that's t and s. Okay, and we said we only have to go out to 1 and negative 1. And 1, 2, 3, 4, 5. And now I try to plot these crazy points here, right? Let's see. 0, 2, that's pretty easy. 1/6, 9/4. Now 9/4 is only a little bit higher than 2. I'll just kind of go like that. That's my vertex. It's a maximum. And then I had what? Negative 1/3, 0, and 2/3, 0. Negative 1/3. It's about 1/3, and positive 2/3. Okay, and that's it. And I just draw my upside down U shape. Something like that. Okay, so there we go. And my axis of symmetry. It's always x equals something. What is the x? 1/6. Sorry, if you can't see that, that's 1/6. I'll raise it up for you there. 1/6 and 9/4. Axis is 1/6. Here are my intercepts. Negative 1/3, 0. 2/3, 0. This was 0, 2. And that's pretty much about it. I don't know why this thing switches to yellow on me, but be that as it may. Okay, so what time is it? Go a little bit longer than we break. All right, so I've shown you how to graph when it looks like this, and also when it looks like this. I've shown you some to go up and some to go down, right? You can tell if it goes up or down by the a, the coefficient of the x squared. Positive means parabola opens up, vertex is a minimum. If A is negative, parabola goes down, vertex is at a maximum. Okay. Axis of symmetry, axis of symmetry. Always a vertical line, or we can just say axis. Okay, and now, what do they want for these? 21, 23, 20. Determine the input that produces the largest or smallest output, whichever is appropriate. State whether the output is largest or smallest. So 21, 23, 25. Okay, show you a couple of those. So what do they want me to do there? So it says determine the input. That means find the X. Find the X value for the vertex and determine is it a maximum or minimum. Okay, so A is 2. That means the parabola looks like this. That means the vertex is going to be a minimum. All right, so I use the formula X is negative B over 2A. So negative 4, right? Negative B, negative 4 over 2 times A. 4 divided by 4 is 1. And I know it's a minimum. Okay, that's all they want. Maybe that was too easy. 23. Same thing. G of X is negative 6x squared plus 18x. Okay, there's a negative. So does this parabola open up or down? It goes down. Therefore, the vertex is a maximum. Okay, so they just asked for what is that value. So X is negative B over 2A. So negative B, negative 18 over 2 times A, 2 times negative 6, which gives me negative 18 divided by negative 12. Negative divided by negative is positive. And let's see, 18 over 12 reduces to 3 over 2. And I know it's a maximum. Okay. So that's that. Okay. And then 27, 29 is just one step further. Find the maximum or minimum value for each function and state whether it is a maximum or a minimum. So now they want you to keep going and find the y coordinate and then just say if it's a maximum or a minimum. That's all. Okay, so I'll show you that and then maybe we'll break right after that. And I do see a question in the chat perhaps. So 29, y equals negative 2x squared minus 3x plus 2. Okay. Okay, the problems. Okay, so I'll give that to you before. Remember, you have all the homework assignments on this sheet in theory. Okay, the syllabus I gave you on the very first day, you should have all the assignments. If you're missing it, send me an email. I can email it back to you. Remember, way back on the very first day, and even before that, before class started, I sent it to you several times, right? For the problems. Okay, does this parabola open up or down? Down, because A is negative. Therefore, the vertex will be a maximum or minimum. Maximum. Okay, so X is negative B over 2A. So negative 3 over 2A, 2 times negative 2. So that's going to be negative 3/4. Now, find the maximum value. I just got to plug that in. That's going to be a little bit uncomfortable, but that's the way it goes. So f of negative 3/4 is negative 2 times negative 3/4 squared minus 3 times negative 3/4 plus 2. Okay. So negative 3/4 squared is 9/16. Negative 3 times negative 3 is plus 9/4 plus 2/1. See, cancel 8. So common denominator is 8, multiplied by 2, multiplied by 2, multiplied by 8, multiplied by 8. I'm trying to get a common denominator, right? So this 2 16s cancels to be an 8 here. So I force that to be an 8, force that to be 8. So my common denominator is 8, right? So now I have a negative 9 plus 9 times 2 is 18 plus 2 times 8 is 16. Okay, so whatever that is. 9 plus 16, 25/8. And that's a maximum. And there we go. Okay, let me raise this up again so you can get the focus better. Okay, all right, it's a good time to break. So I'll stop for a while. 11:58, so how about 12:10? Start up again at 12:10. I'll type that in the chat also, okay? So break until 12:10, please. Okay, folks, 10 after, we'll try to pick up. So the sooner we start, the sooner we can end. Okay, so I was almost done with this section. I have some of these at the end, 37, 39, and 41, and then I'll get started with 4.5. So it's kind of just a review of this F circle G and G circle F stuff. Okay, so the functions F, G, and H are defined as follows. So they see f of x is 2x minus 3, g of x is x squared plus 4x plus 1, and h of x is 1 minus 2x squared. Class of that function as linear, quadratic, or neither, or whatever. Okay, so I'll do a couple of those. So linear means that you can make it look like mx plus b, like letter F. F is linear. G and H are both quadratic. They have x squareds in them. Okay, so they're asking what happens if you do F circle G or whatever. Okay, so I think I'll just do a couple of those, and then that's it. Okay, so 37 as for F circle G. So that's F of G of X. The one that looks like fog. F of G of X. Okay, the next step is to put G of X right here. So what was it equal to? X squared plus 4x plus 1. Okay, and now this thing behind my finger goes into the function F. It goes right in there. So it's 2x minus 3. It's 2 parentheses minus 3. 2 parentheses something minus 3. Like that. Okay, so that's 2x squared plus 8x plus 2. Okay, it's plus 2 minus 3, right? Plus 2 minus 3 is minus 1. That's an easy step, right? Distribute, 2x squared plus 8x. 2 times 1 is 2, 2 minus 3 is negative 1. Okay, and that looks like it's quadratic. So the answer is that it's quadratic. Okay. And maybe I'll just do a function composed with itself. I'll do 41, f of f, and then that's about it. And then I would mark that off and I can get started with 4.5. F circle F is problem number 41. I forgot to put the number down, sorry. Problem 41. So f of x. So what was f of x again? 2x minus 3, right by my thumb there. 2x minus 3. And now this thing behind my finger goes back in to 2 times blah, blah, blah minus 3. 2 times whatever is behind my finger minus 3. So that thing goes in there. Okay. Again, I'm pushing you a little bit to try to do this in your head. 4x minus 6 minus 3. 4x minus 9. And that looks like it's linear. Okay. All right, so I'm done with 4.2. 4.5 is applied maximum and minimum problems. Okay, you're going to maximize some quantity or minimize some quantity based on what they give you. Okay, so if I only do about half of 4.5, then that's good enough. Okay, I still have 4.5 and 4.6 tomorrow, and we're fine. I mean, to cover the material needed for the test, there's plenty of time because I was planning to start chapter 5 next week. And remember, as long as I keep the schedule, I'm actually still far ahead. So if I start to fall behind by 1 day or 2 days, we're good. I still have almost 7 days of buffer that I haven't used up yet. Okay, so 4.5 You can skip 4, 3, and 4, 4. We're not scheduled to do them. 4.5, maximum and minimum problems. So you take all these words, okay, somehow translate it into a quadratic equation. You'll find the vertex, and the vertex will either be the maximum or minimum as we're trying to find, depending on what the words say. Okay. So I'll do some today and do some tomorrow. Okay, so 4.5, 1 to 7 odd. Okay, so I'll do several here. And when I feel like I've had enough, then I'll stop and we'll call it a day. Okay, so number 1, 4.5. Okay, and for those of you that aren't getting the book, page 266. Okay, so 1 through 4. There's 5. Okay, 7 through 23, roughly. So 7, there's 9. Some more. Okay, and how far do we have to go? Forgot, 23, 23A, I guess. Yeah, there's 23A. Okay. This would be a major topic when you get to calculus. So we're setting you up for calculus. In calculus, you're trying to maximize or minimize a quantity quite often. Okay. Number 1, 2 numbers add to 5. What is the largest possible value of their product? Okay, 2 numbers add up to 5. How about I'll call them X and Y? So 4.5, page 266. Call it X and Y. Okay, the numbers add up to 5. X plus Y equals 5. Which means I can solve for Y. Y is 5 minus X. Agreed? If I subtract X on both sides. Now, what is the largest possible value of their product? Number 1. Product means you multiply. So I want to maximize X times Y. And I know that Y is 5 minus X. Okay. So I pick this up and plug it right into here. And I can rewrite this as negative X squared plus 5X. And I want to maximize this quantity. So maximize this. So there we go. Okay, so they told me the 2 numbers have to add up to 5. X plus Y is 5. Solve for Y. Maximize their product, X times Y. But here's Y, the letter Y. Okay, this is a parabola which opens up or down. Minus sign means it opens down, which means the vertex will be the maximum. So there we go. So find the vertex, sneak in some space over here. So for the vertex, X is negative B over 2A, negative 5 over 2 times negative 1, which is a positive 5 over 2. What's 5 minus 5 over 2? 5 minus 2.5 is another 2.5. Also 5 over 2. So what is the maximum product? So the maximum product is when X and Y are both 5 over 2, 5 over 2 times 5 over 2, which is 25 over 4. So my answer is 25 over 4. Okay, so we're saying out of all possible combinations of 2 numbers that add up to 5. What's the maximum product? 25 over 4. You're not going to get higher than 25 over 4, which is 6 1/4. You won't get anything higher than that. That's what we're saying. Okay, there's no graph for these. Notice we're not doing the graph, but if there were a graph, the highest point would be 5 over 2, comma, 25 over 4. Okay, so you take the words and try to come up with an equation, a quadratic equation, and then you maximize or minimize as the case may be. Okay. So that's the idea behind this one. Again, you're welcome to put examples of this on your cheat sheet, on your formula sheet. Say, I don't remember how to do this kind of stuff. Just put it on your formula sheet. Okay, I'll just go ahead and do more. 3. The difference of two numbers is 1. Number 3. What is the smallest possible value for the sum of their squares? Okay, so what does that mean? Okay, you have x and y. The difference is 1. X minus y equals 1. Okay. If I move the y over, I have x equals y plus 1. Move the 1 over, y equals x minus 1. Okay. So I'm solving for y, add y, subtract 1. Okay, now it says something about the sum of their squares. Sum of the squares means you square the one number, you square the other, and then you add them up. So I square x, and I square x minus 1. And you're trying to minimize this. Okay, sum of the squares. So one of them is x, the other is y, but I found out y to be x minus 1. So it's x squared plus y squared, sum of the squares. Yeah, let's multiply this out. X squared plus x squared minus 2x plus 1, or 2x squared minus 2x plus 1. Okay, I want to minimize this. This is a parabola which opens which way? Opens up. A is positive. So the vertex will be a minimum. That's what we're trying. And by the way, they're never going to trick you, and I won't trick you either. If it's supposed to be a maximum, it'll come out to be a maximum. If it's supposed to be a minimum, it'll come out to be a minimum. It will never go against what you think it should be. Right, so I just find the vertex and then go from there, right? So the vertex is at x equals negative b over 2a. So what is negative b? Positive 2 over 2 times a, 2 times 2. That's 2 over 4, or 1/2. Okay, if I plug in 1/2, y is negative 1/2, right? Plug in 1/2. All right, so the sum of the squares, is 1/2 squared plus negative 1/2 squared, which is 1/4 plus 1/4, which is 2/4, or 1/2. Okay, so the minimum value is 1/2, looks like. The minimum value of the sum of the squares is 1/2. Okay, so again, we're taking all these words, these funny words, try to come up with an equation. Once we have the equation, you just look for the vertex. Okay, when you get to calculus, you learn other techniques of finding maximum and minimum values. Okay, these only work for parabolas. When you get to calculus, you find maximum, minimum of all kinds of other shapes also. Okay. Five. Among all rectangles that have a perimeter of 25 meters, find the dimensions of the one with the largest area. You want to maximize the area of all rectangles that have perimeter 25 meters. Okay, so how do you do that? Okay, how do you find a perimeter? 2L plus 2W, right? So 2x plus 2y equals 25. Okay, solve for y. Move the 2x over. 2y equals 25 minus 2x. Divide by 2, divide by 2. Y equals, now let me say 12.5 minus x. Then it says you want to maximize the area. Find the dimensions of the one with the largest area. So area is length times width. So it's x times 12.5 minus x. So that's going to be negative x squared plus 12.5x. And you want to maximize this. Okay, it's a parabola opening downward because of the negative. If the parabola opens down, your vertex is a maximum. Are we looking for a maximum? Yes, we are. Okay, so it always works out the way that you want it to be. Okay, so the vertex is at negative b over 2a. So negative 12.5 divided by 2 times negative 1. Okay, I'll bring that back upstairs. So vertex is x equals negative b, negative 12.5 over 2a, 2 times negative 1. So that's negative 12.5 divided by negative 2. It's a positive 6.25. Okay, that's x. Y is 12.5 minus x. So y is 12.5 minus 6.25, which very conveniently is also 6.25. Okay, so they're asking for the dimensions. So the dimensions are 6.25 meters by 6.25 meters. In other words, the shape is a square. Okay, so to maximize the area, if the perimeter is going to be 25, okay, the perimeter is 25, how do you maximize the area? Make it into a square. Okay, so that's how that one goes. All right, then let's see. 7, what is the largest possible area for a right triangle in which the sum of the lengths of the two shorter sides is 100 inches? Largest possible area for a right triangle, sum of the lengths of the two shorter sides is 100 inches. The sum of the lengths is 100 inches, it says. Okay, solve for y. That's easy. Y is 100 minus x. Okay, then it talks about doing what? Maximize the area. Largest possible area. How do you find the area? 1/2 base times height. X times y. Why is this though? which is going to be, let's see, negative 1/2 x squared. 1/2 x times negative x, right? Negative 1/2 x squared. And then that times that is 50x. And you want to maximize this. The parabola is going to open down. That means the vertex is going to be a maximum. Are we looking for maximum? Yes. So it'll always turn out to be the way you want it. Okay, so vertex formula, x is negative b over 2a, negative 50 over 2 times negative 1/2. What's 2 times negative 1/2? It's negative 1, which is 50. And if x is 50, y is 100 minus 50, it's also 50. So it should be 50 by 50 to maximize the area. Now, answer the question, what is the largest possible area? I just find the area now. So it's 1/2 base 50 times height 50. 1250 square inches, looks like. Okay. Okay, I was going to do just one more, 11. Almost looks like I'm just about doing them all, but that's okay. I'll let you do some others. Okay, and I'll stop after 11. What time is it? 12:35-ish. Okay, so if you have any questions, put it in the chat or unmute yourself after this. But once I do 11, I think I'm going to call it a day. So I've done what I needed to, which was all of 4.2 and maybe half of 4.5, and I can save the rest for tomorrow. And then I'm not going to give you an in-class assignment today. I have to save time to go to my meeting, so I'll just quit as soon as I finish this in a few minutes. Okay. So where are we? 11, and that'll be it. Okay, 11. A baseball is thrown straight up. Its height as a function of time is given by this formula: negative 16t squared plus 32t. So instead of x and y, it's t and h, but otherwise it's the same kind of thing. Okay, h is in feet. This is feet, and time is in seconds. Okay, whoops, I dropped this thing here. All right, so what do they want for A? Find the height of the ball when t equals 1 second and when t equals 3/2 of a second. You just plug in for A. I'll do 1 and you do 3/2. H of 1, negative 16 times 1 squared plus 32 times 1. That's negative 16 plus 32, which is 16 feet. So the height's 16. And yet the second part, plug in 3/2. Same thing, only it's a little bit more complicated. Okay, B. Find the maximum height of the ball and the time at which the height is attained. Okay. So figure out the vertex. So t is negative b over 2a. So negative b is negative 32 over 2 times a. 2 times negative 16. Negative 32. It's 1. We already got the value at 1. It came out to be 16 feet, right? So the maximum height is 16 feet at t equals 1 second. Okay, that's all. And let's see, well, there is a part C, but I don't think we need to do that. So let's skip part C. At what times is the height 7 feet? You have a messy equation that you have to throw in the quadratic formula. So let's skip it. So skip 11C, put that down here. So 4.5, skip 11C, how's that? Which means I've done 1 through 7 and 11, and that's pretty much it. Okay, so I'm done, folks. So tomorrow I'll do the rest of 4.5 and get started with 4.6 over here. So I'm still able to keep the schedule, it sort of looks like. Yeah, so I'm exactly on par right now. So tomorrow 4.5 and 4.6, Thursday will be your next quiz. Okay, all right, that'll do it for today, folks, unless anybody has a question. So if you have a question, put it in the chat or unmute yourselves right now. Otherwise, we're going to call it a day. Okay, so anybody have any questions they want to ask? Okay, I don't see anything or hear anything. So that's about it, folks. All right, so have a good afternoon and we'll see you tomorrow. Okay, bye, everybody. Have a good day.